So I'm going to talk about code quality, and I want to talk about how can we improve quality of code as we develop software. There are maybe about 4 kinds of people. There are these what kind of people. They want to know what do you do? And then there are these how kind of people. How do you do it? And then there's of course these when kind of people, maybe managers. When are you done? And then of course there's this last people who are maybe I belong to, which are the why kind of people. I always want to know why. Why are we doing it? That way I feel motivated to do it, or maybe there's not enough reason I wouldn't really bother doing it. So I want to start with the question, why should we really care about code quality? What's the reason for it? And I'm going to say probably there's one really good reason to really care about code quality, and that is we cannot be agile if our code sucks. As simple as that. So if we, this is not moving at the pace it's supposed to move. Let's try this here. So one of the biggest challenges is we cannot be really agile if our code sucks. We are in a meeting, and remember what agile development is. Agile development is about making change based on feedback, and even inviting change even late in the game. And you're sitting there in a meeting and you realize, wait a minute, the change they are suggesting requires me to change the XYZ module. And the last time I touched the XYZ module, I couldn't go home for the weekend. I'm going to convince them this is not something we should work on, right? So code quality is very important. But I think there's another reason why we should really care about code quality. Because code quality is how we tell our colleagues how we feel about them. Do we love them, or do we hate them all? And when you have the code, it's usually how, by looking at the code, you kind of say, what was this programmer thinking? What did we do to this person to have written all this kind of code, right? It feels that way a lot of times. Well, it turns out lowering quality of code lengthens development time, as the first law of programming says. So we definitely want to improve the quality of code if we want to maintain agility and improve speed in what we do. So I want to talk about how do we improve the quality of code. But the first question though is, what is quality of code? And you probably will find as many definitions for that as the number of sources you read. But I once worked with a guy who had a really weird way of defining code quality. He said, this code is great because I wrote it. I don't think we should have a definition like that. So we should definitely not have such biases. So how do we really define the quality of code? Well, here's my definition of quality of code. I'm going to say the quality of code is inversely proportional to the amount of time and effort it takes to understand it. If a code is really good quality, we take a lot less time to understand it. If a code is a poor quality, we spend more time with the code to understand it. So I would say the quality is reflective of the amount of time it takes to understand it. So we're going to talk about 12 ways to improve the code quality. I'm going to start counting down some of these ways. Well, the first one I'll start with here is going to be rather non-technical, and that is to schedule time to lower technical debt. Well, we all have heard the term technical debt. It was coined by Ward Cunningham when he worked on financial projects. And he said, just like the financial industry has technical debt, as financial debt, we accrue technical debt. Well, what happens if an organization or an individual does not take care of their financial situation? It leads to financial bankruptcy. Likewise, projects unfortunately end up in technical bankruptcy, whether we want to admit it or not, or whether we have the courage to admit it or not. So we really have to take the time to pay the technical debt along the way. But when it comes to software projects, one of the things I do when I walk into client sites and companies is I ask them, you do have technical debts, but where are those written down? So one of the very first things I want to see in the work area is technical debts written down on the wall in the order of highest priority to lowest priority. So I can see every day when I come to work, I can see what my technical debts are. Because if it's not written down, it's not seen, and we tend to forget it too often, and then we keep brooding over it in meetings. So writing it down on the wall in the order of priority, highest to lowest, will help really well. And once we write it down, then we can do something really about it. But one of the saddest things about technical debt is you don't have to do anything to start accruing it. You have this application you just deployed yesterday, And that's using the product version, let's say 4.7.3. And then 6 months goes by, that framework is 7 versions ahead. Whether you do anything or not, that's going to change. And if you don't keep upgrading, you come to a point where it becomes almost impossible to upgrade in a sane way, and that's a debt that accrues on you very quickly. The second problem, of course, is, oh, that schema has kind of been developing over time, the requirements has been changing along the way, and the schema is kind of bent, and we really need to start working on it, but we haven't really had the time to do it. So a lot of these things start accruing technical debt. However, writing poor quality code is not technical debt, it's an intentional sabotage. We can't just put terms to it and say, oh, it's a technical debt we have accrued, so we got to be very careful about it. So we can do something about these technical debt, but what can we do about it? It doesn't have to be an all or nothing proposition. So once we identify these technical debt and write them down, we can then come back and say, well, here's the one that is hurting us the most. We need to really pay attention to this. He's going to spend 15% of his time on this technical debt number 1. He is going to spend maybe 15% of his time on the debt number 2, and so will he on the third one. And we can start dividing this among the team members to give focus on what they can focus on reducing technical debt. They could have other people working with them in this case, but we don't ignore it, but we bring it into the fold and say, we're going to start scheduling time towards it. So when it comes to projects, what do we normally do? We schedule time for development, and we do a lot of time we schedule for development. Then we schedule, of course, time for planning, and then we schedule time for meetings, we schedule time for vacation, and so on, and sickness. Some companies schedule time for vacation. Some companies don't schedule for vacation, and people tend to take more sickness time, kind of works out. But the point really is, we tend to put these times together on projects. But one of the things we also should do is actively start scheduling time to pay technical debt. And if we don't put specific time on our schedule, maybe during sprint planning, then we really don't put a very active effort into fixing it. But in addition to technical debt, I want to also talk about one other thing. And I learned this from this wonderful lady. And when she said something, it really shook me because she made some really interesting things for me to open my mind and think about it. I'm talking about Linda Rising, and she's used the metaphor. And the metaphor that she used was, she said that a freeway filled with cars is a parking lot. And that is so true when you really think about it. If you have a freeway and you start putting cars and cars and cars on it, very soon the cars start going at maybe 2 or 3 kilometers per hour. And it almost feels like a packed parking lot in front of you. Well, that's exactly true about your own schedule as well. If you fill up your schedule with all the work to do, then we all know one thing as technical people, nothing we take actually gets done on time. Things always slip. And if you have packed your schedule, you never give wiggle room for it, we have already set up for failure already. So we need to really have wiggle room in our schedule when we start scheduling. But one other thing she said was, she also said that if you never have, as an individual, as a team, as an organization, if you never have slack time on your schedule, you will never be able to innovate. And that really shook me because I'm a consultant. If I don't work at a client site or on a client project, I'm not billing somebody. So my incentive is to pack my schedule with all the client projects and work as I can. And when I heard her say that, I realized that me, who's working for the client continuously, is like a candle that's being burnt. And in 2 years, I'm going to be burnt, and I have nothing else new to do. When the world changes, I need to be ready to do that as well. So I started injecting about 2 weeks on my schedule when I absolutely don't do any client work. And having the 2 weeks when I don't have to do anything is wonderful, because I can then do all those things I really wanted to do, but I never got a chance to actually do. And also to have time during the week and during even a single day, just giving, I call this the my time, and just having that 15 minutes of my time where I don't do anything for anybody else, but focus on what I am curious about to learn and investigate makes a big difference. I can tell you, every single project I work on in the past several years have absolutely come from out of that my time where I spent time learning and exploring something and investing in myself. This also is given quite a clarity with this book, which is called The Guns, Germs, and Steel. And Jared Diamond talks about the time when humans were pretty much hunter-gatherers. They were savages. They had to go out and hunt every day. And when they had to go and hunt every day, the day they don't go hunting is the day they're going to starve. And then humans discovered they could do agriculture. They started collecting grains, and they started domesticating animals. And this was phenomenal because, well, Bernie gets up in the morning, and Bernie didn't have to go hunting. And Bernie could sit around and have a good time, and when there's time to eat, can get some grains from the store and eat it. And of course, can spend the day playing with this little nice lamb, and when he's hungry, he could just eat it. And this is amazing, isn't it? So, well, what are you going to do if you're not going to go out to hunt today? And well, that's when art started being created. That's when people started creating music, and civilization and culture started growing along the same time. So that's exactly to our work as well. If you don't have to go to work and work every single day, and you have time to invest in other things, we might be able to really invest in tools that can make us productive, and in turn really make us better in what we do as well. That comes in to help us a great deal. So to have the ability to schedule this time for paying technical debt and to have slack time becomes extremely important. The next thing I'm going to talk about is to favor high cohesion. Well, cohesion is something we all talk about quite a bit. Cohesion is where a piece of code is narrow focused and does only one thing. And we want to really make the code very cohesive. But why should we really make the code cohesive? And the reason for that is to really minimize the frequency of change to the software. And that's what we really are trying to do, is to minimize the frequency of change. So a software system has to change over time. If somebody tells you that they wrote a piece of software but they never ever changed it, what they are telling you is the project got canceled. Any relevant project has to change over time. Well, in this case, you don't want to change the software by changing a lot of it. So you want to keep the change minimum as you go through it. So you want to minimize the frequency of change of software. Well, it turns out we can understand about this by looking at the cyclomatic complexity of code. When the complexity of code is very high, the cohesion is pretty low. You want high cohesion and you want low cyclomatic complexity of code. Well, when it comes to code, we tend to ignore this quite often. This is one of those principles we all know, but unfortunately as time goes on, all these thoughts just kind of linger in our minds but doesn't really translate to the code. I was in a client site and one of the developers said, hey, come over here, I'll show you something. And these guys have been developing software for a good 30 years. It's a little overwhelming for me when I go in and see, because some of these people wrote the very first line of the code in the software 30 years ago. And they've been working that long. The version control has 30 years worth of code in there. And this developer drags the timeline and puts the cursor on the timeline 15 years ago and shows me the day when that function was born. It is beautiful. It was small, red behind its ears, little fingers, the cutest chub you could see. And I'm admiring this beauty of this little code the day it was born. And he points me to the corner of the screen where the cyclomatic complexity is shown, and the value is a beautiful value of 5. And as I'm admiring it, he says, now let me show you how the code looks today. And he drags the timeline, and in front of me I can see this code turn into a monster. And then the current day state of the code. And the only thing I can recognize in this method is the name of the method. Everything else is different. Very many number of parameters to this method. Very long, very complex. And then he points me to the cyclomatic complexity, a value of 864. Where a value of 10 is considered to be complex, and he looks at me and says, that's what we do to code in this company. It's kind of scary when the code kind of goes like that and becomes overly complex over time. So we know we should really make the code cohesive, but we end up code that is actually not cohesive and really hard to deal with. So we definitely want to make the code cohesive, and because cohesion really makes it easier to maintain software and also reduces the frequency of change as well. Well, the next thing, of course, is we want to lower coupling. Well, sure, we want to lose coupling, that's what everybody tells us, but I want to go a step forward from that, and I don't want just loose coupling. If I can, I want to eliminate coupling, not just have loose coupling. Now, think about this for a second. Tight coupling is really bad. I'm going to think of the worst keyword in Java. I'm going to say the worst keyword in Java is the keyword new. Because when you use the word new, what happens? You are saying, I want to tightly couple to that class whose name I'm providing. In fact, the entire frameworks like Spring and other things exist just to solve the problem of not depending directly on the classes. That's a very complex problem. The slew of abstract factories come in just to solve that problem. You don't want tight coupling. Well, we have learned that we can have loose coupling by depending on an interface rather than depending on a class. So we tend to really create interfaces to reduce the coupling and to make it loose coupling. But I would argue we need something a lot better than that. This reminds me of an experience. I was in a conference where it was an open space conference. There was no talks given by people. Well, developers got together, selected a topic, got into a room and talked about it. And one of the topics in the conference was, we love automated testing, but the test doubles, the mocks and the stubs make it really hard for us to maintain these tests. So I was very curious about this topic. So I walked into the room, stood by the door, and I was listening to this about 30 people in the room talking about how they are so passionate. They write automated tests, they write unit tests every single day. But then after a while, the project becomes really hard to maintain because these test doubles really make their lives really miserable. After listening for about a few minutes, I interrupted and I said, hey folks, I have a little comment or a question maybe. I'm just curious, maybe you're having all this trouble with your automated tests just maybe because your design sucks. And by saying it, I made everyone in the room really angry. And they said, who are you? Why would you come in and tell us our design sucks? And I said, well, I write a lot of design that sucks. I thought you guys are like me. Well, one of the developers said, let me explain to you the problem I'm dealing with, and we'll talk about how you would probably solve it. So he puts the little problem on the table and talks about, this particular class has a dependency on this other class because it needs to get the data from it. And I realized what he's explaining, I would probably call it as an incidental coupling. An incidental coupling is where you have a perceived dependency from the problem statement, but that doesn't mean that's what it really exists in the system. And we do this quite often. And the next morning I wrote a blog post where the title of the blog post was knock out before you mock out. So the idea is I want to eliminate dependencies rather than dealing with the dependency or loosening it, because if you get rid of the dependency, the problems are a lot easier to deal with. Well, let's talk about one of the ways we could probably do this. So here is an example of a class on the left, and then of course the middle one is talking to the one on the right, which is the red one. Well, let's say the class on the far right is non-deterministic and slow and maybe really hard to work with. So, but I want to write automated tests on the code in the middle. Maybe I'm writing 20 different tests. Well, if I'm going to write 20 different tests, every single one of them most likely is going to deal with a mock object or a stub for the dependency, and that becomes really hard for us to program. Well, what we could do instead of that is realize that this code in the middle takes an input right there from the left one, but then it also gets some data from the right class. So we can argue maybe rather than doing it, we could invert it. So for example, let's say if I ask you, could you please get me water to fill up this glass? Well, the immediate question is going to be, well, let's see, this glass, it's got some weird shape. It's got a smaller volume in the bottom, a bigger volume in the top. There's a curve here. And then, of course, do you want it up to the brim or do you want a little less? And now you notice we are arguing about this glass and you're leaving me thirsty when I wanted water. So the point really is, instead of that, we could simply ask, I don't care about your glass. Tell me how much water you want. Do you want 12 ounces of water or in milliliters? Whatever it is, we don't need to be dependent on this information. We could really decouple from it. So the idea really here is, what if we tried to move things around? What if the code in the middle, which was in the middle, can be given these two arguments, and then of course the code in the far left was able to get this data from the red class and get that over to you. So the point really in this case is we didn't quite remove the dependency, but we moved the dependency, and that becomes a lot easier to work with, and it reduces makes it easier to write the test on the for right class. Now, well, we wouldn't need any stubs or marks or test doubles on the right one. Well, but wait a minute, doesn't that really make the code on the left really more complex and hard to test? And the answer is no, it doesn't, because the interaction that we had a minute ago is very fine-grained from the blue class to the red class. On the other hand, this interaction from the gray one to the red is more coarse-grained. We don't really need to have that many tests around it for that interaction. Well, the next thing I want to talk about here is to program with intention. Now, we tend to really program accidentally sometimes. It reminds me of an experience a few weeks ago. I was at work and I was rewriting a piece of code, and as I was rewriting this code, I was looping through and calling a method with the argument from this particular collection, and the minute I called it, it didn't work. So I told my colleague, well, that didn't work, what should I do? He said, try index plus 1. And I tried index plus 1, and the test immediately failed. And I looked at him and said, that didn't work, what should I do? And without missing a beat, he said, try index minus 1. I kind of stared at him and said, are you serious now? He said, okay, let's really understand what the code is doing. That is not programming. That's called coding in desperation, right? We're trying to throw stuff together and see if it's going to work. That's not going to be helpful at all. So we really need to think about programming with intention. We have to program very deliberately. And so I came across this particular sentiment, and I think it just nails every one of our feelings. It said, when I wrote this code, only God and I understood what I was doing. Now God only knows. So this is so true, isn't it? Because you look at this code and you are absolutely don't have a clue what this code is actually doing. Sometimes, I'm sure you've gone through this, you look at a code and you are in denial. You are saying, I bet you aliens wrote this, because nobody on the team would have written this. And then you discover your name on the version control, and you don't have a recollection of ever writing this code, and you're like, really, did I write this? And you're trying to remember the day when you actually wrote it, right? And that's what happens after a while. We can't remember writing some of the code, and it's really hard to understand what the code is actually doing. This is one of the reasons I'm really a big fan of Ken Beck's rule of simple design. He says that to follow these 4 rules, he says the code passes all the tests. There's an implicit assumption right there that there are actually tests for the code, but the code passes all the tests. Then he says it reveals the intentions, no duplication in code, and finally fewer elements. I'm a huge fan of the last one, which is the parsimony or minimalistic design. Sometimes people really hate me for this because I'm always like, can we reduce it, can we reduce it, can we reduce it? Because I'm of the opinion the code you did not write has the fewest bugs in it. So I would rather not write a piece of code if I don't have to write it, keep it really minimalistic so we have less to maintain as well. So, but he says that these are in the order of high priority to low priority. If there was a conflict between 2, the one in the top takes precedence over the bottom one. In other words, we definitely want to reveal intentions more so than avoiding duplication if there was a conflict between the 2. Well, this is one of the reasons why I'm a huge fan of writing tests before writing code, because if I write a test before writing code, it forces me to deliberately think about what the code is going to do, and that can be very helpful to think about what we are going to code before we get a lot of complexity into it. So we want to really program deliberately. The next thing I want to talk about here is to avoid primitive obsession. Now, this happens a lot when we program. Primitive obsession is where we write code at the lowest level possible. We write code in so many ways to do things that could be done with a higher level code very easily. And it's very frustrating when this happens. We had really good tests, that's a good news, but I was looking at a piece of code a few months ago, and I was looking at this function, and within this function, there is 30 lines of code which is doing string manipulation. And I'm looking at this and saying, you know what, this gives me a really weird feeling. Why did this programmer take the effort to write this code, 30 lines, to manipulate a string? And I was thinking, and I want to emphasize this, when you sit down to write a piece of code, ask yourself this question: am I the chosen one? Because if you are the chosen one, you should be writing this code. And if this code is very specific to your application, very specific to your domain, the chances are you are the chosen one. Celebrate that. But if the code is so generic and common, the chances are somebody was chosen a long time ago. And they have written this code, and I bet you they wrote the code a lot better than what I could do with it. Because they were chosen, they focused all their effort writing that piece of code. I am just writing it as part of my own application. I am not going to invest myself into that code as much as these guys would have done. So if I'm not the chosen one, I should reuse the code and not rewrite it. And so that's a thought that went through my mind at this point. And immediately I started searching. And to my shock, I found a method right there in the JDK that did exactly what those 30 lines were doing. And all I did was I quietly commented out the 30 lines of code, put this one call to the JDK method, made sure all the tests were still passing, and I quietly checked in the code, didn't say a word. About an hour went by, I saw the code change in the version control. So I was curious, I did a pull and looked at the code. Well, the developer who had written the code originally saw that the file had changed, went there to look at what I had done in refactoring it, noticed that I quietly commented out the entire code and made this one call, and then he highlighted the commented code, deleted it, and checked in the code quietly. That's a really good way to learn sometimes, is to realize all that effort you put in to write, it was not needed at all because somebody had written the code already. Well, I'm also going to say that the code we write at a very low level can be very difficult to maintain. And I'll say that imperative code is packed with accidental complexity. Now imagine I give you two 5-kilo little stones, and I ask you to tie them on your wrist and start coding. How painful it's going to get after a few minutes. That's kind of like imperative style of coding. You're sitting there and working too hard the day to do this. Let's look at an example of what this really means. Let's consider one little example to see what this would actually mean in reality. So I have a function that says is prime to return a prime number. If given a number, it's prime or not. Well, the main is calling the compute method, but focus on the compute method. What is it doing? It gets two numbers, n and k. What it wants to do is to find the total of the square root of the first k prime numbers starting with n. Well, I want the square root of all the primes, but only k of them, but that starts with n. Let's be honest about it, it's a problem that's relatively simple. It's not a very complex problem. It's not a problem that requires, extensive research and analysis. A problem is simple. A solution should not be any more complex than the problem. Well, what happens if a solution is complex? When the solution becomes complex, it creates more problems for you to deal with than the original problem wanted you to deal with. So how would you solve this particular example? Let's say we're going to use the imperative style that we are all used to. So what am I going to do? Double result is equal to 0, return result. So I'm going to return the result right there. Then what do? Int index is equal to n. Int count equal to 0. So what did I do so far? Absolutely nothing useful. All I did was wrote all these variables. And then you're like, wow, there's a lot of work in today. Well, these variables have a special name. These variables are called garbage variables. They are garbage variables because they're not needed by the problem. They just came here because of the solution we used. In fact, I'll tell you one sign you're using garbage variables. When you're writing code, you normally don't call them as result or index or count. You would normally call them something like temp and then f and c. The way you'd write it is because you're showing your contempt to the variables to say you don't deserve to live, but I have to use you. And that's how we express our emotions on this code as well when we write this code. So once you write this, what is the next thing you do? Then you say while count is less than k, and your mind comes to a screeching halt, and you ask that unnerving question, is it less than or equal to? Do you ever ask this question? Every single time. There is only one purpose for a code like this. It is intended to make us feel stupid. Because you write it and you feel absolutely silly. You're thinking, is it this or this? You're trying to put this together. We're never sure about it. And it's confusing. And then you go a little forward and you pause and say, did I get this right? And you're never sure about it, right? Well, then what do? Then you say, if is prime of index is true, then I'm going to say result plus equal to math dot square root of index, and you compute the value for it. Is this code correct? No. What am I missing? I have to increment the count, I heard you say. Okay, I will do that. Count plus plus. Is it correct now? Increment the index. Okay. Index plus plus. Is it correct now? No. What is wrong? Oh, it should be outside. Fine. Is it correct now? No. This should be inside. That should be outside. How do you feel about this? Is the code correct now? Did you notice you went from no to I'm still thinking? I'll tell you one thing though. Programmers are the smartest people on earth. Because when you show a code like this to a programmer and say, is it correct? They'll very smartly say, it looks good. They never will say it's correct. Because they know, because if they ever said it's correct, 3 days from now when you see that it's not correct, they're in trouble. You know, it only looked good. So they're very, very smart about it, right? So you have this code right there. So what are we going to do now? Let's go ahead and run it and see what it does. Right there is the result. Is it correct? It looks good. That's all I can say, right? So here's the solution. But if you look at the solution, this is an example of accidental complexity. It is an accidental complexity because the torturous code right here did not come from the problem. The torture here came from the solution we used. And we have been doing this for a very long time. My only fear is 400 years later, humans will see this kind of code in the museum and they will have a laugh of their life. And they will look at us and say, do you know what these guys were doing back then? And that is the biggest trouble I have, is looking down from heaven or hell. I don't know where I'm going to be, but when I look down, I'm going to look down and say, shut up, we didn't know better back then. Well, at least we could try. So what am I going to do here? Let's try to write this a little differently using the functional style. Well, the beauty of a functional style is it's declarative. It reduces the complexity quite a bit. So I can say return a stream dot iterate. And in this case, I can say, given the value n, and start incrementing from e to e plus 1. And then I'm going to say dot filter, get me all the prime numbers starting with n, but get me all the square root of all the prime numbers starting with n. And then I'm going to ask it to do one other operation, which is dot limit k. And you could say, is it less than k? Is it less than or equal to k? It's k, damn it, keep moving. And then, of course, I can simply say sum to do the operation on it. So when you look at this, the code has a lot less complexity compared to the top code, as you can see. Not just fewer lines of code, but the sheer complexity has been removed. The moving parts are really gone from this. So rather than having to go back and forth with these multiple variables, we simply said, given a collection of all the values starting with n, give me all the prime numbers starting with n, give me the square root of all the prime numbers starting with n, but give me only k of them and do a total of it. It becomes a lot easier to work with. So I have this theory about these kinds of code. When you look at the imperative style code, I feel there is one thing that imperative style code does. It is code like that prematurely turns programmers into managers. Because this young developer comes to work, struggles with this for a few, maybe months to years, and says, I am done. I'm going into management. I will let you clowns deal with this. So the people in this room, there's a special name for you all. We are the survivors because we came back every single day to work and said, I can handle this. And you wipe your sweat and get back to work, right? And not many people, he's got tears in his eyes already. I feel your pain. And that is how it is that it's really hard for us to do, but we do it. But when it comes to the functional style code, I feel, this is what I feel about functional style code, a good code should read like a story, not like a puzzle. What we write shouldn't be like a puzzle. The code we've been writing is like a puzzle. And what happens when you write a puzzle? Your colleagues don't understand it. Sometimes they may take a few hours, sometimes they take a few days, sometimes even they take a few weeks to understand. You are working quietly in your office and suddenly you hear the scream in the next room and you pause and say, he got it finally, right? And this is not helpful for projects because people take this enormous amount of time to understand the code. That becomes really, really hard. So we want the code to read like a story, not read like a puzzle. Well, it turns out the imperative style code is where we tell what to do and how to do it. Well, in the declarative style code, we tell what to do and not how to do it. One of the reasons why functional programming is so exciting is not just because it's functional, it's because it's declarative. Well, declarative program, every piece of functional code is declarative, but not all declarative code is actually functional. So that is one of the biggest trends we are enjoying is functional style is actually declarative plus the higher order functions. Well, the next thing I'll talk about here is to avoid clever code and write clear code. We all have this desire to write clever code. Now, why do we write clever code? Honestly, we write clever code because it feels really good. You write a piece of code which is clever, that proverbial hand comes and pats you in your back and says, oh, you are so awesome. And then we are like, this is great, I'm going to do more of this tomorrow. And this only becomes a vicious cycle over time, right? So it just becomes very, very exciting to keep writing this clever code. Well, I have an experience where a client wanted me to solve a particular problem and they described what the issue were. And I looked at the problem and I said, oh, you know what, it's going to take me 10 minutes to solve this problem, but no, I don't want to solve this problem. I want to solve the meta problem because it's so much more fun to solve not just a problem, but any such problem from ever happening again. I'm going to put an end to those things. And that's how smart I am, how cool I am, right? And I spent an hour doing this. When I finished it, I had an out-of-body experience. Venkat got up from the chair and came and hugged me and said, you are awesome. It felt that good. And I checked in the code and I walked so happily. I didn't solve problems today. I solved meta problems today, right? Well, a couple of weeks went by. I got this email from the client saying something terrible has happened in production. I looked at what happened, immediately replied back saying, I got this, I can fix it. They said, oh, we know you'll fix it because you're that good. I replied saying, no, I can fix it not because I'm good. I can fix it because I'm the one who caused it. And what was the problem? Well, the clever code I wrote had totally backfired in ways I never actually imagined. So what did I do? I quietly rolled back the code I put in and did the 10 minutes of work that I should have done in the first place, fixed the problem that actually we know about, and I never heard about it after that. And a lesson really learned. These days when I sit and write code, the minute I realize this code is clever, I delete it and start over. Because I don't want clever code, I want clear code. That is something that we should strive for. What a beautiful code this one is from Abelson and Sussman. Programs must be written for people to read and only incidentally for machines to execute. So we really want to think about readability of code, not the effort we take to write it. So sometimes we try to innovate and come up with very smart ways to implement code, but machines may really be able to deal with it. But when a fellow developer comes to maintain it, they have a really hard time and they waste a lot of time. This is one of the things I'm becoming more and more sensitive. I always ask the question, not how much time and money it took for me to write it, how much time and money it's going to take for another developer to touch it. If it's going to take more money for them to touch it and change it, I'm not doing a good service writing this code, so that becomes very critical to deal with. I'm going to say 10% of the time we write ugly code for performance reasons. The other 90% of the time we write ugly code just to stay consistent. And that way we don't feel guilty about this. And I was at work a couple of weeks ago when a very young developer came and sat on the chair with a big thud and a big sigh. And I said, having a rough day at work, aren't we? He said, let me ask you this question to you, Venkat. I was in this other room in a meeting, and this developer had written a horrible code. And I asked him why this code is so horrible and ugly. And he said he had to write it so horrible and ugly for getting good performance. So I want to know what you think about it. I said, I will answer that question to you, but before I answer the question, let me ask you a question. Does that ugly code have good performance? And he said, that's the problem, it doesn't. And that is where we end up a lot of times in code we write. So those who sacrifice quality to get performance may actually end up getting neither. So when you realize the code doesn't perform very well, you are pretty much stuck because nobody wants to touch it, and becomes extremely hard to improve the performance of such a piece of code that becomes really hard to work with. So we want to really write clear code, not clever code. Tony Hoare says this really well. He says there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other is to make it so complicated there are no obvious deficiencies. So we want to really focus on making the code very simple and clear. That's very critical for us to do. The next one I want to talk about here is quite a bit of an odd one, because this came from rather a non-technical book. And I was reading this book, and as I was reading the book, I kept screaming, my gosh, everything he says in this book is not about English, it's about writing code. And this author absolutely did not talk about coding in any stretch of imagination. But I got this book as a gift, actually, originally. I started speaking English when I was about 18 or 19 years old. And I really had a lot of trouble writing English. The people who had to read my English in the beginning, they were not called editors. They were called as victims. And they had to read what I wrote. And one such victim took pity in me and said, you really need some help. Here's a book, read it. And that's how I got this book. And when I read this book, I was so impressed about this book. It's a very old book. It's written 30 years ago by this gentleman called William Zinsser. Mr. Zinsser passed away a few years ago, but he left something really wonderful for the humankind. It's a book about writing English, about writing non-fiction. If you want to write an article or a book or a technical blog, what are the things you should consider in writing better English? That's what he is talking about in this book. And when I'm looking at this particular book, what I noticed was he had some really beautiful recommendations in this book. And one of his good quotes in the book is, he says, hard writing makes easy reading, easy writing makes hard reading. And so if you put a lot more effort in writing, people find it very easy to read it. If you don't put much effort in writing, people put a lot of effort reading it and it becomes really hard to read it. So the point really in this case is, I liked a lot of things, and I liked it so much that I kept talking about this book all the time. And at that time, my son was 10 years old, who is 14 now, and he has usually a summer reading where he would write down the names of maybe 20 to 40 books that he wants to read during his long summer holidays. And when he was 10, he said, hey, Dad, I keep hearing you talk about this book. I want to include this book in my reading list. And then he said, can I borrow that book from you? I said, no, don't touch my book. It's my little precious. And I went and got him his own copy and said, it's yours, you keep it. And he came back and he said something really interesting. He said, it's not a book to be read, it's a book to be reread. And he has read this book almost every summer since then. And I know because he would quote things from this book without even looking at it, that's how much he has actually read the book. And so I'm very convinced about this book. It's really good, but it was written for writing English. But he lays out 4 principles for writing good English. And it came striking to me because those very 4 principles that he says are good for writing English are also good for writing code. And you would absolutely agree the minute you see at least a few of them. The very first principle he talks about in this book for writing good English, he says, is simplicity. And can't we all agree that that's one of the things we strive for when writing code as well? He says when writing English, you have to keep things very simple, because if what you're writing is very complex, you're going to lose the interest of the reader of your book. And so he says simplicity is very important. And of course, what causes a lack of simplicity in our code? Well, when you have a lot of mutability, when you have low cohesion, you have high coupling, the code becomes not so simple and very difficult to deal with. The next thing he talks about is clarity. He says when you write something, you got to make it very clear. Now, I have written books, I've written theses, I've written articles. I've also read other people's writing. These days I read more books before publication. Publishers contact me and say, would you review this book and give us feedback? So I'm pretty much taking the brunt of the author like I had given it to other people. And when I read these authors' writing, I notice something they do, which is a common mistake I have done myself. And that is, this author knows the content in their head, in their mind, but when they start writing it, they talk something here and then suddenly talk something over there and suddenly talk something over here, and there is no flow through the logic and becomes really hard for us to understand. So in writing for clarity, there's got to be really good flow in writing. Same thing in code as well. When writing code, you are looking at this piece of code and you're not sure what this author, the programmer is trying to do, because there is no flow through the logic in the code. Becomes really frustrating. So we definitely want to really have good clarity in code. The next thing he talks about is brevity. He says shorter sentences are better than longer sentences. Shorter paragraphs better than longer paragraphs. Shorter chapters better than longer chapters. He says shorter books better than longer books. I do have to admit to you, I have more open books than the books I've actually read. I'm very eager to read books. But when I start reading a book, in all honesty, I lose interest in about the 5th page or the 10th page. I'm a man of impatience. And if by the 10th page I'm not excited, it doesn't matter how wonderful the technical content is. If the author has not helped me to read it, I leave the book unread. And I have these books in my office or at home still open on that page unless the wind has blown the pages up. And I don't even go ever back to them because I just don't like to read them. Then one day I was asking the question, there are a few books I've read cover to cover. I would not put them down. I would take them on the trips when I travel. I would read them continuously, and I would not put them down until I was done with the book cover to cover. And I asked myself the question, what really makes it interesting for me to read books? And I noticed one reason I read books, and that is the books I really enjoy, when I look at a page, there are almost never they have a page with one big paragraph in it. What they have a lot of times is maybe 3, 4, if not 5 paragraphs in a page. And I realized something. You know, normally when I go on a client visit, I'm in a remote town all the time. I would finish my client work, I'd go to dinner, and oftentimes I would carry a book with me to dinner. And I would order food, I would open the book, and I would start reading. And I'm usually there until the restaurant closes and everybody is gone. And what I would notice is I would read a paragraph, and after read the paragraph, I would be looking out the window. While my eyes are looking out the window, my brain is very far from the window. It's analyzing what I have read. I'm thinking about it. I'm building a story about it. I am experiencing what the author said. And then I would move on to read the next paragraph. And I realized when the paragraphs are small, the author is respecting the reader. The author is saying, I gave you a piece of information, but I'm going to give you some time to think about it and then come back and reflect on and move on to the next thing. It's exactly the same thing I tell my developers when I do code reviews. I tell them, if you write a function where everything is like this, you are not caring about the reader. But even one blank line, just one blank line, you are sending such a very important message to the reader. I did one action now, I am transitioning to the next action now. And that one line is a gold when it comes to code. So often in my code reviews, I keep telling developers, put a blank line here, please, put a blank line here, please. And that's one of the reasons to really do that. The last thing he talks about is humanity. I first rejected this. I said, humanity? We don't care about humanity. We are programmers. We write code and the compiler can deal with it, right? And I realized how wrong we are. When we work with developers, if we think of humanity, the design in the code is actually much better. And that is something we have to really work towards. I remember an experience where I was at the optometrist and she was looking in my eyes and examining, and she said, "What do you do for a living?" I said, "Oh, I'm a programmer." A few minutes goes by and then she is talking about other things, and suddenly she said, "What do you do for a living?" I said, "I'm sorry, I think I told you that I'm a programmer." She said, "Yes, you did, I heard you, but I just wanted to make sure because you look almost normal." And some way we are giving this impression to people that somehow if you're programmers, we should really be antisocial and we shouldn't really talk to people. Well, in all honesty, I'll be honest about it, I travel a lot, which means I'm stuck in an airplane for about 9 to 15 hours at a stretch. 9 to 15 hours is beautiful time to do a lot of work. So I would get into the airplane, and the minute I sit down, my laptop is open. I'm working on either writing some code, writing an article, maybe writing a chapter in a book. Easily you can finish a chapter, at least the first draft in a flight like that. So I don't want to even talk to the person next to me. So I'll be the most antisocial person in airplanes. I'll sit down, I'm focused on coding. I'm not going to turn around and look at this person. Don't even bother speaking to me. But then I would get a little wind that the dude next to me is a programmer and she has been coding, and I'm like, whoa, I realize you're a programmer. We turn into a riot at this point because we got so much to talk about, right from garbage collection to exception handling, and you cannot just have enough of the flight time to do it. And that is one of the most interesting things. This truly happened actually. I was on a flight. This was one rare occasion I was in a business class, but this entire business class was vacant. And I sit in my seat, this lady sits in the seat next to me, and then she says, "Well, looks like the business class is totally empty. I'll wait for others to come in, but if no other seat is occupied, I'll move." And I thought, that's kind of rude, but that's fine. And now I know why she was rude, but anyways. But I said, you know what, that's fine, you can move anywhere you want to, but if every seat is filled, and if you still have to sit here, I'll be more happy if you sit here, that's fine. And I kind of pretend that it's all cool. And then, of course, I went back to work. And then a few minutes later, she kind of looks at me and says, I was actually writing Scala code. I can imagine why she said this, but she looked at it and said, "I can't imagine humans are still doing this." And I kind of like, did she speak to me? I kind of like, "Excuse me?" And she said, "I can't believe humans are still doing it." I said, "I'm sorry, are you talking about me writing code?" And she's like, "Yeah, I can't believe that we have to keep writing code like this." And I was very surprised she said this because she thought I was human, but anyways. But then I said, "Yeah, what do you know about programming?" And she's like, "Oh, I used to code when there were punch cards." I'm like, "Punch cards, let's talk about it." I'm not kidding with you. In this flight in 8 hours, the flight attendant came several times and said, "Could you please be quiet? You're making too much noise here. There are people who want to sleep and you guys keep talking." And that's the beauty, right? The minute you find this other person is a geek, you cannot just resist it. So the point really is, I have this theory that we are not antisocial, we're just social among the right kind of people. That's the way it is. So that is the beautiful thing about it. Absolutely, we have to think about humanity. We cannot ignore it. The next thing I want to talk about is something that really hit nerves on people, because some people feel that they have to comment every single line of code they write. I want to emphasize, comment why and not what. I want to write comment to tell me why the code exists, not what the code is doing. And I really, really, really hate comments that tell me what the code is doing. I want the code to be self-documenting and self-describing. If somebody comes to me and says, "I don't understand this code," comment it. I say, "Timeout, I don't understand this code," refactor it. So I want the code to be refactored, not to be commented. And so I want the code to be self-documenting and easy to read, easy to understand. And that is something very important for us to do. And I'm going to say a good code is like a good joke. And when you tell somebody a joke, What if they don't understand the joke? The worst thing you can ever do when people don't understand your joke is start explaining it. Because this doesn't go well at all. Because when you finish explaining it, those people look at you and say, oh yeah, so what's funny about it? And you're like, let me re-explain it. It's going to be a very long evening. So there's only one right response when you tell a joke. You say a joke and people don't get it, you immediately say, never mind. Just don't go any further, just never mind. So they tell you a joke, you say never mind, and then you go home, sit in a corner, and you think about how the day went. And then you refactor your joke. And then you try this with a new group of people and see how it goes. So a good code is like a good joke. Commenting a piece of code is like explaining a bad joke. So we really want to focus on making the code self-descriptive, self-explanatory. But unfortunately though, a lot of times people want to write comments to explain code as to what the code is doing. The other day I saw a piece of code which did something beautiful. It said increment right next to it. I was so thankful. I said, you know, as I'm getting older, my eyesight is not really good. And when I look at this, there are times I don't know whether it's plus plus or something else. So it's so wonderful for these people to take care of me. They said, Grandpa, I know you don't see this very well. I'll put an increment comment for you. They're very kind of them. But the point is, you know what? I can zoom in and find it too. They don't need to put this comment. And also, the other day I saw this beautiful code where it said X and then 2 with a beautiful shift next to it. You know what? I get it. It's a shift. But what I don't know is, what is X? I don't know. Why there is 2? I don't know. Why are you shifting? I don't know. So a lot of times these things are really left out and it becomes really frustrating. So what if the code can be self-documenting so that we don't have to really keep documenting and telling what the code is doing? So I came across this. I was in Washington, D.C. to speak in a conference, and I wanted to take a shower before I went to give a talk, which is usually a good thing. So I got into the shower. And the minute I got into the shower, I was about to open the shower, and I saw this, and I got so angry. Well, we live in a world where when you're very angry, you don't take shower. You tweet about it. So I jumped out of the shower right away, grabbed my smartphone, and took a photo and tweeted it. And my tweet said the following. And because the reason I had to tweet was, I felt intellectually insulted, in all honesty. Because I looked at this and said, you rascals, why can't you give me a shower I can actually use? You have to document it. So my tweet said, those who cannot design are condemned to document. And this has just gone overboard in my opinion. You go to the shower and they have to tell you in words how to use it. You go to a door and they put in words pull. And you don't know what to do about it because you keep pushing it still, right? And to make things worse, the other day I had common cold. And I wanted to really take some tablets to cure my cold or at least help with my cold. So what did I do? I took this bottle. I was about to pop 2 tablets but I saw something written on the bottle. So I was kind of curious. It said, let me read it. So I strained my eyes to read it. And it said, take 2 tablets by mouth. And I'm like, what other ideas are you giving me right now? So this is like ridiculous, right? So why do you have to tell me take 2 tablets by mouth? I think that should be obvious unless otherwise intended. And so the point is, I think the lawyers are at it. They try to really put all these things into the documentation so they can frustrate us. So A order 3, what in the world is 3? Well, let me comment it. Oh no, why don't we use a more descriptive enum maybe so it becomes self-documenting. So document why the code exists. Tell me the purpose of this code. Tell me the preconditions and post-conditions. Tell me the exceptions. But don't tell me what every single line of code is doing. I can figure out what the code is doing, tell me why the code exists, and the constraints around it. Well, the next thing I want to talk about here is the so-called, about long methods. Long methods are evil. Well, let me ask you this question. Who here thinks long methods are a good idea? Not a single person raised their hand. Let me ask you a different question. Who here has seen long methods at work in their own code? Hands start going up. Other people are very reluctant. They're like doing this, right? They're like so painful, they don't want to do this. Yeah, so this is called cognitive dissonance, right? Everybody knows not to do it, and yet there is code at work. I'll tell you why you have long methods at work. I know the reason for it. You didn't write it. Because you just told me you don't believe in it, right? You didn't write it. Well, the sad part is, the people who believe long methods are a good idea, they're not here today. They're at work right now making those methods longer as we speak. And that's the sad part about it, right? So they are writing those long methods. So long methods are bad, but why? There are several reasons why long methods are a bad idea. Long methods are hard to understand. Long methods are hard to maintain. Long methods are hard to debug. Long methods are hard to test. Long methods lack cohesion. Long methods have too much coupling, the diagonal opposite of what a good design is. The other day somebody said to me in a very grim voice, he came to a realization, he said, do you realize long methods become longer? That is so painful to think about it, right? I travel a lot. So when I go home, I always look at my kids and say, hey, you are taller than I saw you last time. I don't want to come to work and say, hey, you method, you're bigger than I saw you last time. That's not a good sign. So the point really is, the long methods become longer. Long methods lead to duplication of code. Long methods are hard to reuse. I mean, we could keep going with this, right? But yet people keep writing long methods. So the question is, why are we writing long methods? Let me ask you this question. If I tell you I have a method which is 10,000 lines long, would you agree it's long? Yeah, okay, yeah, absolutely. 1,000 lines, what do you think? Still yes. 100 lines. Still yes, okay. 50. There are a few yes and others are like, okay, fine. You should be, the 50 lines okay are not okay are usually these Ruby programmers in the rooms, right? And then I'm going to say 10. And the Ruby programmers are like, okay, Clojure guys are like, what, 10? It's too much. Well, there's one thing we know. We cannot put two programmers in a room and come up with a consistent value for what a long method size is, because the industry has no agreement on it. The other day somebody said in a very nice way, he said, hey, I know how to define a long method. I said, go for it. He said, a method is not long if you can fit the entire method in a window. And immediately somebody said, what's your font size? This doesn't work out at all, right? So we can lower the font size and get more things into it. Why bother? Well, okay. Well, it turns out we've been looking at it wrong. So I'm going to explain it in a slightly different way. Let's say you have this colleague who writes long methods. You have told this colleague, don't write long methods, please. The colleague doesn't listen to you. So there's one last effort you can help this person to realize. So you go back to work on Monday morning. Don't say a word, just sit down and start working. Your colleague, the one who writes long methods, comes to work and says, hi, you're early at work. How was your weekend? You could tell your colleague how your weekend was like this. You could say, oh, the weekend was great. On Saturday, I went to the park with a park. On Sunday, I went to the movies. But don't say it like that. Instead, you say, oh, the weekend, I'll tell you. At 7 o'clock on Saturday, I took the car out of the garage, took a left turn, rode for about 7 kilometers, took a right turn, and went for another 20 kilometers, took a left turn, and then drove for another 7 kilometers, but missed my exit. How darn it is. Had to turn around and had to wait in the traffic light for 15 minutes to 10. Can you believe this? And then I went for another 17 kilometers, and then took a right turn. Just keep going like this. At some point, your colleague will say, have you gone mad? You say, no, I've not gone mad. I thought I'll tell you how my weekend was, like the way you write code. And the point really is, when we talk to people, we don't talk to people like that. How do we talk to people? We say, I went to the park on Saturday and went to the movie on Sunday. Oh, really? What park did you go to? Oh, the one by the main street. Oh, I've heard about it. Is that family friendly? Oh, yes, I took the kids. What kind of activities do they have for the kids over there? Notice we are drilling down into this abstraction one level at a time, leaving the movie aside, we don't care about it. That's exactly what we want to do when we write code, and that's called the SLAP principle. The SLAP principle says single level of abstraction principle. So it turns out we really need to focus on the levels of abstraction and not on the length of the method. I've often heard people tell me the reason they don't like shorter methods is there are way too many short methods they cannot remember. That's a sign we have taken the methods and broken them into small chunks without considering abstraction. We want to really think of abstraction and level of abstraction. This actually helps. I do a lot of code reviews, and invariably one of the recommendations I've had for one developer particularly was to break this method into smaller methods, break this method into smaller methods, break this method into smaller methods. This went on for like many months. And one day my review was, merge these two methods into a single method. He came right back and said, I don't get this. You always tell me to break methods into smaller methods. I thought I figured you out, and now you take a U-turn and you tell me merge these two methods into one. I don't get it. I said, oh, I'm really sorry because I've been telling you what to do. I haven't told you why to do it. Well, the reason I ask you to split these methods often is they are two different levels of abstraction. They don't belong together. But today in the code I asked you to merge, these two methods really are in the same level of abstraction. They don't actually belong separately. They can be together. So what I'm looking for is not the length of the method. What I'm looking for is the abstraction in the methods that really are the boundaries to think about. So that is something we should really strive for. The third one I want to talk about here is give good, meaningful names to variables and methods. They say one of the most difficult things for programmers to do is name variables, right? I have a definition of what a programmer is. A programmer, one who can name their children quite easily, but has a hard time naming their variables. You can pick children names very easily, but these variable names, they seem to be haunting us. We got to spend way too much time thinking about it, right? So we have to really struggle hard, but variable names are very important. I was working at a client site, and this particular product, by the way, a single license to this product is $1 million. It's a very intensive engineering application, a lot of science involved in it, a lot of engineering involved in it. And I was at the site and I said, we were going through code and they flipped through one code and they jumped over to another file. I said, oh, whoa, 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 can you go back to that file? And they did. I said, can I please take a photo of this? And they said, as long as you don't tell who we are and don't show anything else, absolutely go for it. So I took a photo. I'm very thankful they let me take a photo of the code, and here it is. Oh, sorry, this is not what I took a photo of. What I really took a photo of was the line below this. It said, God help me, I have no idea what this means. These are developers writing the code, and somebody had left this. I feel like this is what I see. You see a comment like this, and then you look down, there's dry bone in the bottom. This is the last call from the programmer before they died, right? And they couldn't handle this anymore. And so when people ask me, what do you do for a living? I don't tell them I'm a programmer anymore. I tell them I'm a software archaeologist. Because I go to work and I try to figure out what this code means. And then when we talk about it, we hypothesize. I think this is what the code means. And one of the developers says, but remember it was winter time when they wrote it. Oh, okay, let's think about it. So we kept trying to figure out what the code is doing, and that's really, really hard to work with. Variable names represent abstraction, so we have to really think about them very well. If we cannot name a variable or a function appropriately, it may be a sign we are not yet understood its true purpose. The next thing I want to talk about here is to do tactical code reviews. I know a lot of people there thinking, are you out of your mind? You are asking us to do code reviews. Well, unfortunately, code reviews have become a very political and emotional passions. In some companies, they bring the team together in a room, they project the code on the screen, and they start talking about it. This is called a bad idea. Because Sarah says, I'm already behind schedule on my code. The last thing I want to do is come listen to the stinking arguments you guys have all day. I'm going to skip it. Joe, in the meantime, says, you know what? You guys are going to look at my code. I'm going to call in sick that day. I don't want to take this. In the meantime, the boss says, wait, this code review thing, is it this kind of thing that you did last month on the Thursday? Oh, yeah. Heck no. Because the last time you guys did it, there was a fight. They had to call the cops and 2 people quit. No more code review for you, right? So people don't like to do code reviews. But I found extreme value in this. And if you ask me if there's one thing I do very, very thoroughly, that is code review on my own projects, actually. I invite people to review my code as well. And one of the reasons I do that is, well, the one clear reason is the benefit I get out of it. But keep in mind a few things, though. You are never reviewing code. You are always reviewing the person, whether you like it or not. It is very emotional. It is very difficult to separate the person from the code, however saintful we can all be. So the minute you start talking about the code, they're going to get really agitated. So one of the things I recommend is never say what's wrong in the code. Don't say things like, gosh, I'm looking at this code. I could not see where it begins and where it ends. How horrible this code is. Where do you go to school, by the way? You don't want to be really insulting people like this, right? So don't get emotional on them and personal on them. Instead, always make recommendations. Hey, I'm looking at this code. Do you think we should split this into 2 functions, maybe 3? Maybe these could be the functions. Always suggest what to change rather than what's wrong with the code. And one of the other things I do very thoroughly these days is I not only review the code, in fact, I don't review the code until I finish reviewing the test. So by reviewing the test, you can ensure they have actually written the test as well. And also, there is one thing I did about 7 years ago that I've made it as a practice ever since. About 7 years ago, what I used to do is I would review code and I would find bugs in code. And when I find bugs in code, I would write a paragraph. I would say, hey, looking at this function, if you send a value between 200 and 300, it'll give you this result which is not right, blah, 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 blah. And that day it occurred to me, I could write this paragraph and walk away, but it would be a lot more fun if I wrote an automated test that fails because of this bug. It took me about 10 to 15 minutes that day to write this test. And I wrote this test, the test failed, and I just checked in the test quietly, didn't say a word. The automated build, continuous integration server, ping, goes out and says, test failed, and it broke the build. By the way, I'm perfectly fine with breaking builds. And so when the build broke, the developer who wrote the code gets a notification, and I got the notification too, which I very summarily deleted. And the other developer looks at this email and says, oh, look, there's a notification that the test failed. It's the code I wrote. I know Venkat was reviewing it, but it's broken. Let me see what happened. An hour goes by, and he comes to me and says, oh, I see what you did there. You found a bug, and you wrote a test. But did you know there were 3 more bugs in that code? And so when I found what you have done, I wrote 3 more tests now. So if you look at it, there's 3 more tests than the one you wrote. And I pulled up and said, sure enough, there are 4 tests sitting there, which were not there before. And I said to myself, my job here is done. Because when people get into the habit of writing tests before fixing bugs, and then fix the bugs, that's the right thing to do. So we can promote these kinds of behavior during code reviews as well, and I've started doing that ever since. But as a twist, about 6 months ago, I learned yet another lesson. I saw a bug in the code, so I started writing a test for it. I spent 30 minutes on it, and I still could not make the test to fail. And that's when I figured out it was not a bug. The code was so poorly written, I had misunderstood it. So now my recommendation was not, go fix this bug, here's a test. Here are ways to refactor it so that it becomes easier to understand the code. So that can be very helpful as well. So how do we do the tactical code reviews? I write a piece of code, I'm going to give it to him for reviewing. And then the next piece of code I'm going to write, I'm going to give it to him for review. The third piece of code I'm going to write, I'm going to give it to her for review. And I rotate among these people. Just one person reviews the code. Not everybody gets together. In the meantime, the code he writes, maybe I will review it or he will review it. We don't have any senior developer, junior developer kind of mentality. Anybody writes code, it gets reviewed. It doesn't matter whose code it is, it'll get reviewed by somebody else. So that kind of tactical review has been extremely beneficial overall. The last thing I want to talk about here is to reduce state and state mutability. So if you ask me, there's one thing I do differently today than I did maybe 10 years ago, I will clearly tell you that one thing is dealing with fewer states. I used to write code which is bloated in state, objects with a lot of fields and mutations and stuff like that. And maybe it's my learning of functional programming over the past few years that got me excited into this slow transition away from it. Bless you. So essentially, these days when I sit down to write code, I notice this among developers quite a bit. They would sit down and say public class, and the very next thing they do is private something and putting a variable into it. I immediately ask them the question, why are we putting a state right now? I don't want the state to be self-serving. I never want the state to be there just for itself. I want the state always to serve a behavior. So what I tell my developers now is, when you start writing, don't put a field, start writing methods. And when you start writing methods, let a method force you to have a field, and only then reluctantly bring the field over. So I want to minimize the state as much as we can. So my recommendation is to think more typeless, aim for minimalistic, fewer state, less mutability, and just enough code for the known relevant parts of the problem. A little more philosophically, I would say, messing with the state is the root of many problems, both in software and in politics. This is why we go to war with other countries, right? We always want to mess with somebody else's state, which is not a good thing. So generally, it's better to leave the state alone. And of course, mutability often needs company. It hangs around with bugs. So the more the mutability we have in code, the more bugs we often end up seeing as well. So we want to definitely reduce it. So we talked about 12 ways to make the code suck less. So here is the list of the 12 ways we talked about. Schedule time to lower technical debt, favor high cohesion, favor loose coupling, and reduce and remove coupling where you can, program with intention, avoid primitive obsession, prefer clear code over clever code, apply the Zinsser principle on writing to programming, comment why, not what, avoid long methods, apply the SLAP principle, single level up abstraction principle, give good meaningful names for variables and functions, do tactical code reviews, and reduce state and state mutation. One departing thought I'll leave with you. We all write code, we all enjoy writing code, but one of the things we often deal with, unfortunately, is we often deal with teams where developers, managers, business analysts, just about everybody comes to us and says, are you done yet? And they want us to start coding and be done right away, which is insane. I was in Madrid a few weeks ago, and one thing that really attracted me in the museums was one particular wall where they had Picasso's paintings. In this particular wall, what's special about this is they didn't have a lot of his paintings. They had his masterpiece on the far right side. And everything to the left were the prototypes he had created for that masterpiece. It was like aha to see this, because we have always seen this masterpiece and we celebrate it, but you can see these 16 other things he had drawn. The far left one doesn't even look anything like what he wanted to really do. Along the way, he shapes his, his thoughts and then comes towards this masterpiece that we all celebrate. And the point really is, we need to really write the code, but we have to work on refactoring it. So my departing thought here is, the first step in becoming a better programmer is to let go of the conviction that we can code it once and get it right on the first write. And I have the belief now that code is never written, it's always rewritten. So it's very important for us to get to rewriting very quickly. Hope that was useful. Thank you.